Good morning, everybody. Today I'm going to show you how to draw a wall section, and let's try to understand what a wall section is. Okay, let's write here wall sections are drawings which are produced to understand how building elements come together, or alternatively how we integrate them. Okay, so until now in the lectures we have talked about foundations, we have talked about floor systems, external wall systems, and finally last week we have talked about windows and doors. And these three building elements and one structural component is going to come together. They have to be integrated with each other because they are going to form a whole which we call as building. And you know that this term we are talking about steel structured buildings, and I have told you that we have got two main types of methods which we use for constructing steel structured buildings. Let's say that this line is representing the ground line, and let's take this pen of mine, and blue is representing reinforced concrete. So in the first alternative we have an entirely reinforced concrete basement level, and on top of this reinforced concrete basement level we construct a steel structured building like this. Okay, so this part is steel and the lower part is reinforced concrete. And I have told you that the second popular approach that we use for constructing steel structured building is to construct a reinforced concrete pool and constructing a steel structured building from the roof to the foundation level of the building. Okay, so now these lines that we have here is representing the foundation and this line is column here, an RC column, and this is a steel column, whereas this one here is a RC basement wall. Okay, so we'll start with the first alternative, and now let's show you how we draw the alternative. Okay, firstly I'm going to start by drawing a line here. Okay, and that line is representing the ground line. What we have to do is we have to excavate the ground in order to construct the building inside. Okay, and this is my excavation line. Okay, and now I'm going to draw here more thick, and I'm representing ground with that. Okay, and this line I will transform into a dashed line, because what we do, we excavate the ground, and when we are finished with the building we fill it back with soil. Okay, and let's assume that, let's take our paper back down. Okay, and let's assume that this alternative has a strip foundation, and let's make this alternative with a raft foundation. Okay, I do not try to mean that in this alternative the only foundation type that you can use is strip. I don't try to mean that. Okay, we can use in this alternative a raft foundation as well, but in order to show you both types I choose to make this one with a strip foundation. In real life, it's going to be, together with the architect, it will be the civil engineer who is going to decide about the real foundation that will be used in buildings. Okay, but here I choose it to be a strip foundation in this alternative. Okay, we have talked about the preparation steps. Prepare the ground for construction. That's the first step of construction. And what do we try to mean by preparation? We firstly compact the ground. Okay, now we have obtained a straight plane at the bottom of our excavation pit, and we have compacted it, and we have pushed the loosened parts of the soil into the ground, and we have a straight plane. And that straight plane is yet only a soil plane, soil and stone plane. Okay, so it is a natural topography, and we do not want to immediately start constructing our building on soil. Instead, we want to have a clean, hard plane onto which we may construct our building easily. Okay, for doing so, what we do, we cover the entire bottom of the excavation pit with gravel. Okay, we lay a layer of gravel. Gravel are small piece of stone, okay, round with sharp edges, stone, and we cover it. And don't forget that stone, that gravel that we put on top of compacted soil will also going to increase the load bearing capacity of soil as well. Okay, so now we get rid of soil and we have obtained a flat plane which is entirely stone now. It is more clean. Okay, one extra information between these layers, between soil and gravel, we do not want them to touch to each other directly, because in time they will enter into each other. Okay, so what we do, between them we add a separative layer. Okay, that separative layer is usually a geotextile felt, okay, an inorganic textile. Okay, and what we do, on top of gravel, still we do not have a hard plane. Now we have a clean plane which is entirely stone, but we want that plane to be hard as well. So what we do, on top of that stone, okay, we cover it with concrete. Okay, but that concrete, we don't want that concrete to be a high quality concrete. Okay, we just want it to be a hard plane underneath our feet. Okay, because it is already standing on top of the strongest thing ever, which is the earth itself. And what we do, between gravel and this lean concrete, this concrete that we put, we also place a separative layer, which is again a geotextile felt as well. Let's draw a line here. Okay, and let's extend it slightly more because we are going to add a couple of more layers there as well. The lowest level is earth itself. Okay, in parentheses I'm going to write here compacted soil, and on top of it we have a separative layer which is geotextile felt. And on top of that, what we have is gravel. And the thickness of this gravel is something around 10 to 15 centimeters. We cannot give an exact thickness for it because the soil isn't straight. So at some parts the gravel's depth is 12, at some parts 15, at some parts 10. Okay, and then again we place a separative layer again a geotextile felt, and on top we have lean concrete. Okay, so what is lean concrete? Lean concrete is a concrete which is produced with the least amount of cement inside. Okay, and it is around 10 centimeter here. Okay, so let's put a circle here in order to make you see the layers easily. From top to bottom, lean concrete, separative layer, gravel, separative layer, and earth itself. By the way, let's take or go back to our schematic sections here. A wall section is in fact a section which is just showing this part of the building and that part of the building. Okay, so it is not a full size from one side to the other side, full size section of a building. It is a partial section which is showing just the wall and the other building elements which is connected to the wall. Okay, and now we need to add something else here. Firstly, let's extend this gravel until the end of our excavation pit, and let's place here a piece of stone, a stone channel. Okay, and let's place a pipe here. Okay, so what is the name of that pipe? Let's write it here. It is a underground drainage pipe with a diameter of 15 centimeters maybe. Okay, and what we do, we surround that with a geotextile felt as well, because drainage pipes are perforated pipes and are pipes with holes on its perimeter, and those holes are very small, like a rice size of a hole. We don't want those holes to be filled with soil. We want to keep them always empty because we want the underground water to enter into our drainage pipe and to flow on top of this piece of stone, which means that geotextile felt wrapped around the drainage pipe is acting as a filter layer. Okay, and now I will do something else. I am going to construct here a wall, a reinforced concrete wall. Okay, but it is going to look like a retaining wall, but in fact it is not a retaining wall because it doesn't have a proper foundation underneath it. Okay, it is just a weak wall which is constructed for applying waterproofing membrane onto. Okay, and what we do, we fillet this end point of it. Okay, and then I'm going to draw it with blue. What we will do is we are going to wrap it entirely with waterproofing membrane. Like this. Okay, and now what we have made is, in fact, we have made a pool into which we are going to construct our foundation. But don't forget that foundations are made of reinforced concrete, and reinforced concrete have reinforcement bars inside it themselves, and also there are gravel, and both of them are dangerous for the sake of our waterproofing. There is a possibility of our waterproofing to be cracked or to be cut by those members that I have listed. That's why we want to protect it. Okay, protect it from being harmed by gravel and steel reinforcement bars. That's why we are going to cover them with a layer of lean concrete again. Okay, so this lean concrete that we put here is now placed for protection purposes. That's why we are going to name it as a protective concrete. And then in order to protect this the waterproofing on this wall, we are going to cover this part with a rigid foam insulation. Okay, it is a thermal insulation which is placed for protection purposes. That's why we don't need to name it as a thermal insulation. It's a protective rigid panel. And then now we are ready to construct our foundation, which is a strip foundation. Let's draw it. No, I have drawn it wrong. Okay, because when we are directly going to cast it into this pool of ourselves, that's why I need to draw the lines right above the other lines that we have here. Okay, so it is a, okay, I'm going to cut it short and erase this one as well. Okay, because what I want to show is that it is a strip foundation. Okay, and this line and that line are the elevation lines of our strip foundation. Okay, and on top of our strip foundation, what will we do? We are going to construct our column. Okay, and here is our column. Be careful, I'm drawing it with my black versatile pencil, which is a 0.5 diameter, and I'm not pressing hard on it because this column that I have drawn there is not in section. This is the foundation in section, okay, whereas the column is in the background. Okay, what I want to use here is the basement floor. Okay, that's why I want to keep the soil that I will place here not to fall into my basement floor. That's why I will construct here a basement wall like this, and the basement wall, like the foundation, is in section now. That's why I have to erase that line and I have to continue hatching it until the top. Okay, and let's raise the ground line as well. Okay, exactly like this. And what will I do? I will construct a reinforced concrete floor here. Be careful here, look at here, blue represents reinforced concrete material, and the ground floor of our building is wanted to be made of reinforced concrete as well. Okay, but let's wait a second for that reinforced concrete floor, because before making that or drawing that reinforced concrete floor, what I want is to cover here with a waterproofing membrane. Okay, but just pause, let's pause a little bit, and I'm going to fill it here. Okay, I'm going to fill it there slightly, because reinforced waterproofing materials do not like turning perpendicular corners. Okay, that's why what I did is I made it turn a 45 degrees of an angle, and over this wall I just adhered the waterproofing materials onto each other. Okay, and now please follow. I have a continuous layer of waterproofing all underneath my building. Okay, which means that underground water that we may have under the ground, okay, cannot enter into my building, because I wrapped the substructure of my building with a continuous layer of waterproofing. Okay, and then what will I do? I want my basement floor to be a well insulated place, because I want to use that basement floor like a room. That's why I'm going to cover it with thermal insulation like that. Okay, again a rigid foam insulation, like an extruded polystyrene panels. Okay, and another function of that thermal insulation is giving a protection for my waterproofing, because don't forget that we are going to fill this space with soil, and inside the soil we are also going to have some pieces of stone as well, and we are going to throw it from there to here. So there's a risk of those stone pieces to open a hole in our waterproofing, which is something that we won't want. Okay, and we won't want that those soil and stone to harm this part of my waterproofing as well. That's why I am going to cast here a layer of protective concrete as well. Okay, and we have got one last thing left. Okay, I'm going to draw it again with a dashed line. It is a drainage mat, a plastic drainage mat, which is going to generate a small hole, a gap between the thermal insulation and the soil, and which is going to act as an extra precaution for the humidity and for the soil under the ground, because don't forget that we have underground water, and the main resource of that underground water is the rain that we have there. So we don't want that rainwater to try to spend time around my thermal insulation material. Okay, so that's a drainage mat. There's a drainage mat there. Okay, and all underground water is directed to our drainage pipe here. Okay, and around my drainage pipe right here, I am going to generate a bed of gravel. Okay, because I want my drainage pipe to work as a drainage pipe for the entire life of the building. Okay, and this gravel that we place there is going to filter the water which is going to come to the soil filling that we have here, and it is going to help the geotextile felt wrapping of the drainage pipe against the drainage pipe's holes to be filled with soil. Okay, so let's write here, this is bed of gravel here, and we have got a geotextile felt wrap around it. Okay, and now what we can do is we can again draw this line as a thick line. Okay, and I'm going to draw here some grass. Okay, because we have soil filling there. We have buried our building under the ground now. Okay, and then let's write a couple of names here. What I want is I want to erase this soil filling name, and I want to move it slightly left side. Soil filling, I will write it here, because what I want is to draw a line like this here. Okay, and what is the most inner layer? We have got, okay, the reinforced concrete basement wall is the first layer that we have here. Right on top of it we have got water proofing, and on top of waterproofing we have got thermal insulation, and we have got plastic drainage mat, drain mat, I shortly write it. Okay, and then we have soil filling. Okay, let's erase this line. Okay, and let's look at what I want to extend this slightly. Okay, let's extend it like this. Okay, and let's extend here and there as well, and let's extend this also, and of course it will be good to extend the waterproofing as well. Okay, because what we will do here is we are going to fill the space between my strip foundation again with soil, and again I'm going to cover it with gravel, and then I'm going to cast a reinforced concrete slab here like that. Okay, and let's raise this basement floor again, just the text let's raise, and let's draw it slightly top, basement floor, because I want to write the names of here. What's the lowest layer? Here we have got water proofing, and above waterproofing we have got protective concrete, And above the protective concrete, I have got again soil filling, compacted soil filling. Okay, let's put a C here. Okay, I just hurried for writing basement floor. Let me erase it again. Okay, and then what we have is, again, we have gravel, and we have got a RC slab. Okay, and what is this individual component that we see here? It is the reinforced concrete column. We have to write that as well. Okay, and then now it is time to construct our ground floor. Here is our ground floor. Okay, a 15 centimeters thickness of a reinforced concrete slab. Okay, and be careful, I didn't continue this because what I want is, I don't want my my external walls to intersect with the columns. That's why what I do is, I'm going to construct a small cantilevered floor here, like that. Okay, now it's time for hatching all reinforced concrete material here, like that. Okay, and I'm finished with the basement floor of my building. Let's look at this schematic diagram. The reinforced concrete basement wall is this one here. Also there's a column there as well, and this pink line that you see here is representing the steel column. The steel column will be a continuity of the reinforced concrete column, and reinforced concrete column is from here to there. So what we will do, the center of the reinforced concrete column is going to come right under the center of my steel column. And I'm going to tie steel column to the reinforced concrete column by the help of a base plate. And I am going to center my base plate from here to there as well. So the base plate is right here. Okay, this is the base plate. And I'm going to draw some dashed line in order to represent the anchor bars of my steel base plate. And then right above my steel base plate, I am going to place my steel column. Here is my steel column. Okay, and this is the end point of my steel column. And let's say that we see the flange of the edge profile. And the dotted line is the web part of my edge profile, which is hidden behind its flange. Okay, and now it's time to talk about the first level of my building. This level, it is steel, you see. Okay, and what I am going to have here is going to be a steel eye-shaped profile. And let's take my thin versatile pencil, and here is my steel main beam. But the steel main beam is going to be hidden behind the steel secondary beams. Okay, and here is my steel secondary beam. I told you that we cut the top flange of the steel beams and we place it here. The steel secondary beam can be slightly smaller than the steel main beam. And now that my steel main secondary beam is hiding the column behind, okay, I'm going to erase this and I'm going to convert it into a dashed line. Okay, and you know that the floors end at the same line. Okay, I want the first level of my building to end at the same line with the ground floor of my building, and I will do that by the help of a steel cantilevered beam. And here is that cantilevered beam. And I want to make my cantilevered beams act as a whole by the help of a U profile that I have there. Okay, and like the secondary beams hiding the column behind, my cantilevered beams are hiding the column in the background as well. Okay, that's why I erased the column and drew it with a dotted line. Okay, and these are of course connected to each other with plates, with shear tabs. Okay, and these are the shear tabs of that I'm talking about. And right here, what do I have? I have my L profile, and over my L profile I have my steel trapezoidal sheet which is covering the entire floor plane. And of course on top of my steel trapezoidal sheet I cover it entirely with the reinforced topping concrete. Like that. Okay, and from the previous videos you know that whenever we cut a building element and whenever it continues we use the dashed and dotted line to represent that, and here are our dashed and dotted lines. Okay, we are about to finish now. It is not because we have to, it is because I want to. Let's choose masonry walls for this building. And let's choose frame structured walls for this building. Frame walls and masonry walls. And you know that masonry walls maybe the masonry wall, in order to construct the masonry wall you need to have, in a frame structured building you need to have some rectangular prisms made of clay brick, aerated concrete block or pumice block maybe. Okay, and what we do, by the help of a mortar, we start placing our pumice blocks here. And here are my pumice blocks. In between them, I have mortar, which is adhering them to each other. Okay, so I have got mortar here, here, there, and there. And I leave a window opening here. I place a lintel there, okay, and I continue putting my masonry blocks like that. Okay, and of course we cannot say that a masonry wall is finished without a plaster on top of them. Here are the plasters, okay, and here is the plaster again, wrapping even maybe the bottom side of my floor, and I have a plaster here also. Okay, I cannot plaster steel members, that's why I left there empty. And then what I will do is I am going to cover here with a thermal insulation. Depending on the type of our finishing we are going to determine the type of our thermal insulation material as well. And thermal insulation turns around and reaches to the thermal insulation below. Okay, and now what we have to do is we have to place a window system here. Let's place it. Okay, firstly we place a blind frame and another blind frame here, and then we place a window frame and another window frame. This is the elevation line of my window frame, one more window frame and another one here. Okay, it's a pretty small window, and this is the glazing. Okay, and what I will do is I am going to make my thermal insulation turn and reach until my blind frame, and I will make my plaster turn and reach to my blind frame as well. Okay, now what I need to do, I need to raise this line. Never ever please forget drawing the elevation lines. Okay, and these are the elevation lines. Okay, and what I want is I want this masonry wall to be finished with a plaster. So I want it to be an attic type of wall system, externally thermally insulated building fabric. Okay, what I will do, I am going to use a special plaster of 3 millimeters in thickness, a special plaster of 3 millimeters here as well. By the way, I have forgotten to place a window sill here, and here is our window sill. Okay, and then I'm going to paint my 3 millimeter thickness of plaster, and let's draw a line here like that. Okay, the first line that I have there, is my plaster, and the second layer that I have here is, let's say that AAC Masonry Wall core I have, and I have got another layer of plaster. So the thickness of these plasters are around 2 centimeters each. Okay, and my masonry wall, let's assume, is 20 centimeters. And then I have my thermal insulation. Let's say that it's 5 centimeters in thickness. And then I have got my plaster plus paint, which is a total of around 3 millimeters. Okay, and what is this that we have there? It is the window sash. And what is this thing here? That's the window frame. And what do we have there? We have the blind frame. And right here we have the double glazing. Okay, and of course, what is this thing that we have here? It is the steel column. Okay, and let's write the name of these layers that we have here as well. Okay, the layers, the continuous member that we have there is just the steel trapezoidal sheet, and on top of that we have got reinforced topping concrete, and that's all. Okay, what else do we have? We have here the steel main beam, and we have here the steel secondary beam. And what is that here? That's also my steel main beam. And this thing that I have there is the steel cantilevered beam. Okay, that's all, folks. Now what you have to do is you have to draw this yourself. Okay, and the second method that we use for steel structured buildings, in which we continue the steel columns until the foundation, in another video. Okay, see you later. Bye bye.